Hello everyone, welcome to the soft computing lecture series. Today we'll be doing some problems based on the associative memory. In the last lecture we did some theory part of this particular memory. Now we'll do some problems which are based on hetero-associative memory. We'll do this with the one method and another method also. So the given problem is train a hetero-associative memory network using Hebb rule to store input row vectors S1, S2, S3, S4 to the output row vector T1, T2. So this is the given pair. We are given 4 input training sets. The inputs are 1 0 1 0. These are the first input set, and this is the target. This is the second input set, and this is the target. The third, the fourth. Okay, this is the network we have, the hetero-associative network. So it has this input x1, x2, x3, x4. Okay, and this is the first layer. Okay, this is the first layer. Then this is the second layer. So we are connecting x1 with y1 and y2 using the weights w11, w12. Then x2 with y1, y2 with weights w12, w22. With x3 to y1, y2 with 31, w31, w32, and connecting x4 with y1, y2 with this these two weights x41, x42. So in this particular training process, with this training and the target, we need to adjust the weights. We need to find the value of these weights. What will be the final value of this weight when we train this particular network? So I've already written it to save time. So we have the first training set. As you can see, the training set is 1 0 1 0, and for this output should be 1 0. So this 1 0 1 0 is our input, and 1 0 1 0 1 0 is the input, and for that 1 0 is the output. So we set the activation. X1 is x1, x2, x3, and x4. This is what we have written here, 1 0 1 0, and these are the activations, output activations. Y1 is 1, y2 is 0. So we first start with the weights, all the weights, the 8 weights, 1 1 2 1 3 1 4 1 1 2 2 2 3 2 4 2, all are set to 0. Okay, then we start the algorithm. When we start it, so we need to update the weights. Now this updation is done using Hebb rule. So Hebb rule, what does Hebb rule say? Wij new is equal to Wij old plus Xi Yj. This is the rule. So we will do the training for adjusting all the weights w1 1, w2 1, and so on. So we put this value. This old is what we get for all the old values. This all are 0 0 0 0. So using these old values, we find the new values. As we know, for the first part, x1 is 1, x2 is 0. Okay, and as you can see, x1 we require x1, x2, x3. These are the things we will be using. So so x1 is 1, x2 is 0, x3 is 1, and x4 is 0. Y1 is 1, y2 is 0. Using this particular values in this second part of the summation, we get, for the first case, w11 new is w11 old plus x1 y1. So since all the weights are 0, so this is 0, and then x1 is 1 and y1 is 1. So 1 1s are 1, 1 plus 0 is, we get this as 1. Then w21 is w21 old, w21 new is equal to w21 old plus x2 y2. Now x2 is 0 and y1 is 1, but 0 1s are 0, so we get this 0, and so on. You can check the values. We have this as the new weights. So these are the new weights, 1 0 1 1 0 0, and so on. Now this, whatever we have done the calculation, this calculation is now continued for the second training set. Now as we can see, for the second training set, these are the input vectors 1 0 0 1, and this is the output. So whatever weights we have calculated from this particular set, they are taken ahead. Okay, so we repeat the same Hebb rule. Okay, now these are the inputs, and we repeat the same Hebb rule to update the weights, taking the updated weight from the previous calculation as the old weight. So whatever weight, the value of weights we got in training set 1, they will be used as old weight in this case, and we repeat this thing. Okay, so this, whatever this weight old, this is taken from here. Okay, and we find new set of weights taking this particular value. for training set 2, repeat this for training set 3 and 4. So whatever weights we are getting from training set 2, they are taken to training set 3 as the old weights, and we calculate new weight in training set 3, and whatever new weights we are getting in training set 3, they are used as old weight in training set 4. And after that you can check it, the final updated weight what we get is W11 is 2, W21 is 0, W31 is 1, W4 is 1, 41 is 1, W12 is 1, 22 is 1, 32 is 1, and 42 is 1. So this is what we get after calculation. Of course it is a very big calculation, you can try it. Okay, so this was the first one. Now we have the second problem. Now in this case, only difference is that we are using some different training to calculate the weight. We are using some different method. Okay, so train a hetero-associative memory network using outer products method. So we need to use the outer products method, not the Hebb rule, to store the input row vectors S1, S2, S3, S4 for the this is the output T1, T2. Now this is the table we will be using. It's the same thing. Okay, the same network is there, only the method is different. Okay, now in what way the method is different, we can see here. We need to calculate the following for outer product method. We need to do the summation. Now this small p goes from 1 to capital P. In our case we have 4, so this small p will go from 1, 2, 3, 4. For all the 4 training sets we need to calculate this part. So this S transpose, this is the transpose of whatever input vector we have and into the training the target value. Let us see. So see, in the first case, as we know, the first training pair S, the training set 1 0 1 0, you can see the first row, this is 1 0 1 0, right? This is 1 0 1 0 and output is 1 0. So we take this training set 1 0 1 0, find the transpose. Transpose means row gets converted to column and column gets converted to row. So this is a row matrix, it becomes column matrix. This is a column and T is 1 0. Okay. Now P is 1, right? For the first case P is 1. So we multiply this to, we need to multiply, we need to do matrix multiplication of ST with T1, ST with T. So because P is now 1, this is the first training set, so we do the multiplication. So this is the 4 by 1 matrix, this is a 1 by 2 matrix. So the multiplication is possible because this is 1 and this is 1. So 4 rows, 1 column, okay, 1 row, 2 columns. So output will be 4 by 2. Okay, the output matrix of this will be 4 rows and 2 columns. So we multiply this. Okay, so first of all, first row, okay, first row first column, second row second column, third row first column, and fourth row and first column. So we get 1 1s are 1, 0 1s are 0, 1 1s are 0 1, and 0 1s are 0, and then this multiplied by this all with 0. So what we get is 1 0 1 0 and all zeros here. This is the first training set. We do the same similarly for the second training pair. For the second training pair, S is 1 0 0 1, we take the transpose, we get 1 0 0 1. This is the training, this is the target. We multiply both. This is for training set 2, therefore it is 2. So 1 0 0 1 1 0, we multiply this 1 0 0 1 to 1, we get 1 0 0 1, and this is 0. So we multiply this and we get this. Similarly for training set 3, we have 1 1 0 0 as the training pair. We take the transpose, this is the target. So when we multiply, we get 0 0 0 0 and 1 0 0. Similarly for the fourth training pair, we do the same thing. This is the S input and this is the transpose, the target. Multiply them, we get this. Now this was done. Now what is the main output? Main output is summation of whatever trainings we have done. So this is equal to summation of this, means ST1 T1, ST2 T2, ST3 and S4. So whatever matrix product we have got, we add them all together, and the final, this is our weight. This is the weight, the value of the weight. Okay, that is the output we get. Okay, so this is how we solve the problem.